Thank you, ma'am.
So let's start. Hi, myself Shreyas Upadhyay. Me and my team members are here to discuss about the Capstone project. So the Capstone project was about the loan application which was approved by the loan issuer to find the defaulters. And I'm mentor Nikita Tandil and a batch number PGA9. Here's my team. Rachit Agarwal, Shreyas Upadhyay, and Vishwesh Jore. Let's discuss about how the data analytics process works. In data analytics process, the first step is to understand the business problem. The second step is the data exploration part, where we can identify the characteristics and by visualizing the data. Third, the data preparation part, where we can clean the data and impute the missing values, and EDA part. Then the fourth for building the machine learning models, and then the last one, the model evaluation part. This is how the data analytics process works. Here is the quick overview of a loan analysis. First, identifying the business problem. Second, the data description part. Third, visualizations, data understanding. Fourth, exploratory data analysis. Fifth, predictive modeling and evaluation. Sixth, basic user interface for the client. Seventh, conclusion. And the last one, recommendations. Here was a quick overview of a loan analysis. So in every data science project, the first step is to identify what actual the business problem is. So in our project, the business problem was the banks was facing a huge loss due to the maximum number of defaulters. So to overcome this situation, we need to create a best optimal model to predict or correctly identify the defaulters in the future. And this can be only possible by analyzing the historic data and identifying the patterns. So we created a best optimal model to minimize the number of defaulters. So the data description part, we were given the data sets of total 8,55,969 records with 73 features, including the target variable, or we can say the response variable. The data set was highly imbalanced with approx 6% of the defaulters. The data sets contains the variables in categorical, numeric, and date format. The data set contains complete loan data for all the loans of all the loans approved from the year 2007 to 2015, including some features of the loan. Here is some important features of a loan where the loan issuer checked while approving the loan application. The loan amount, the amount of money which is requested by the borrower, interest rate on the loan amount, grade, the grade assigned by the loan issuer with categories A, B, C, D, E, F, and G. Annual income, the annual income of a borrower. Purpose, the borrower requesting or for the applying a reason for a loan. Installment, the EMI should be paid at the regular intervals on a loan amount. Term, the borrower opted for the duration of month for how many terms. DTI is a debt to income ratio, where your gross monthly income is the ratio of a monthly debt payments. So as we discussed already about the identifying the business problem and the data description part. So let's understand more about the data set through visualization. As this graph already denotes that count of defaulters by year. So let's discuss the defaulters as through the year. From the year 2007 to 2011, there was an increase in the number of defaulters as every year. And in the year 2012, there was a double the maximum number of defaulters than the previous year. And from the year 2012 to 2015, there was a significant rise in the number of defaulters. The few factors might affecting the defaulters. This might be the labor scandal, the hurricane scandal, and the hostage filed for bankruptcy. This was the unexpected crisis that could be affecting. So the pie diagram also shows that the defaulters at the statewide the highest number, the top 5 states with the highest percentage of defaulters. So in this pie diagram, we can denote that the state of California shows the highest percent of defaulters with 36.92% of defaulters, followed by New York, the 20.71%, then Florida, 17.72, Texas 15.4, and the New Jersey 9.25. These are the 5 states with highest percent of defaulters. The purpose for loans, as I told, the borrower applying or requesting a loan for the purpose. Here, the maximum number we can from the bar diagram, we can clearly see that the debt consolidation is the main purpose of borrower requesting a loan, then followed by credit card and the home improvement and so on. Here, the debt consolidation means the debt consolidation is the borrower applying for a loan to repay the remaining debt amount. The credit card, the borrower applying for a loan on a credit card for an instant loan. Home improvement for the renovation or for the construction of an home, and then so on. Now further onwards, my team member Rashid Agarwal will take you through the expertise data analysis and building model. Thank you.
Thank you, Shreyas. So as you have gone through the data or what the data set contains, so before prior building the model, it is necessary to review the data, clean it, and prepare for building a model. So here are the few steps that we have done prior building a model, such as renaming the variables, where we have renamed the variables as per our convenience and the domain knowledge. For example, like there was a variable DTI, so we have renamed it to ratio to income and expenses. And the next one is extracting the values. Here we have two variables, employee length and term. So where we need only the numeric part, not the whole string. So in employee length, what we have done, we have extracted the numeric part. For example, you can see that there was a 10 plus year value, which is mapped to 10. 2 years is mapped to 2. 1 year is mapped to 1. Where less than 1 year is directly mapped to 0. The same thing is done with the term variable, where it was having values such as 36 months and 60 months. So we have extracted the numeric part here, 36 and 60. Next. After extracting the values, we have replaced the values of one variable to another variable. This is done based on the application type. So there are basically two types of application in our data set. One is individual and one is joint. Individual, where there is only one borrower, and joint, where there are two borrowers. Like one is the main borrower and second is the co-borrower. So where the application type is individual, the income of borrower will remain as it is, and where the application type is joint, so the existing value of income borrower is replaced with the income of joint. So where income of joint is a combined income value of borrower and the co-borrower. And this same whole procedure is repeated with the DTI or the ratio to income expenditure of borrower. This is done on the income variable. So next variable is home ownership, where we have replaced the values like other, any, and none and clubbed them to other values. Next. After this, what we have done is that we have dropped the variables. Here we have three categories where we have dropped the variables. The first one is that first one contains those variables which are not needed for building models, like member ID, policy code. Member ID where every value is unique, so it is not needed for building models. Policy code where every value is one, so it is not needed. And more variables like employee title, description, zip code, and so on. Second category contains those variables which have more than 50% of the null values, like verified status joined, IL util, month since recent IL, open IL 12 months, and so on. Third, now we have the third category where the variables are where the variables are highly multi-correlated to each other. So here we have set a threshold of zero point 0.7, where collinearity is the relationship between two independent variables, and multi-collinearity is relationship between two or more independent variables. So in our case, we were having loan amount, approved bank amount, and approved bank amount investor. These three variables were highly multi-correlated. So instead of keep using all these three variables, we have decided to keep only the loan amount and removing the approved bank amount and approved amount bank investor. Next. So after dropping the variables, now we have few variables where missing values are still remaining. So instead of computing with the mean, what we have done is we have replaced the data with zero value. So these were the steps which are needed in the EDA part. So now, before prior to building the model, we need to perform few more steps like converting the categorical data to the numeric data. So here we have few variables like grade, home ownership, verification status, payment plan, purpose, state code, initial loan type, and application type. These were categorical data. So we need to convert it to numeric part. So what we have done, we have used the label encoder technique, where label encoder technique, what it does in the backend is first it fetches the unique values that is present in the variable, then arrange them in the ascending order, and then it starts mapping those values with 0, 1, 2, and so on. So here all these three functions like fetching, arranging, and mapping is done in the fit function. While in the transform function, it actually replaces the data in the data frame of these variables. Next. Once this is done, the next come is the train test split. So as mentioned in the document, we need to divide the data according to the issue date, where the training part contains the data from June 2007 to May 2015, while the testing part contains the data from June 2015 to December 2015. So after splitting the data into train and test, next comes then optional approach like scaling the data. Why scaling is needed? Scaling is needed to ensure the uniformity across the data. So basically, there are two methods to scale the data. First is standardization. Second is normalization. So in standardization, the approximate range is from -3 to +3, and as well it is capable of handling outliers. And in normalization, it is having a fixed range from 0 to 1, and it is not capable of handling the outliers. So in our data set, we decided to go with the standardization technique to scale the data. Next. Now the data is prepared and we are ready for building the model. So as Shreyas mentioned earlier, that our main goal is to predict whether the person applying for a loan will be a defaulter or non-defaulter. So here our target or response variable is in binary form. So it is a pure classification problem. And we have decided to use the below mentioned techniques such as logistic regression, a decision tree, and these two are supervised learning algorithms. And third algorithm, fourth is the AdaBoost algorithm. These two, bagging and AdaBoost, are the ensemble technique. And fifth one is the ANN. It stands for Artificial Neural Network, which is a reinforcement learning technique. And sixth one is the voting classifier. Voting classifier is a combination of multiple algorithms, and then it produces the output. Next. So now we need few metrics to evaluate the model, that how well the model is able to perform on a test data set. So we have decided to like confusion matrix, recall score, where recall score is the accuracy of individual classes, precision score that how relevant are the results or how well you have predicted. Then we have F1 score, which is the harmonic mean of recall and precision score. Then we have the AUC ROC curve, and then we have the final overall accuracy of the model. Next. As discussed earlier, we decided to use logistic regression, so which has a default threshold value of 50%, which means that it gives equal weightages to both class 0 and class 1, where class 0 is for not defaulters and class 1 is for defaulters. So here, when we imputed the model, so we found a total error of 151, where the type 1 error, what does a type 1 error means? That actually the person was not a defaulter, but the model has predicted as it as defaulter. So the number here is 88. And type 2 error, where the person is actually a defaulter, but the model is predicted as not defaulter. So it has predicted as 63. So to improve on this results, what we have done is we have tuned the threshold to 70%, means increasing the weightage of class 0 of not defaulters to 70% and 30% of the defaulters. So here we can see there is a reduce in total error from 151 to 104. So you can see that type 1 error has drastically reduced from 88 to 39, while there is a slight increase in the type 2 error from 63 to 65. Right? So to further improve on this, we decided to go with the decision tree, where we implemented the decision tree with the default hyperparameters such as criteria, where criteria is the it selects the variable on the basis how to split the variable. Next is maximum depth, and next is minimum samples leave. That is one. So here you can see this is results for the class one, that is of defaulters. Precision score is 6% and F1 score is 11%, which is not very good. So we decided to tune the model. Like criteria remain as it is, and we have set the maximum depth to 11 and minimum samples leave to 5. So here you can see there is a huge increase in the precision score and the F1 score, which is 66%. So now comes the question here that while we implemented the decision tree, the original decision tree, so has it overfitted or not? So to check on this, what we have done is we have predicted on the training data as well. So from here, you can clearly see that the original decision tree, where we have not tuned anything, just pass the parameters as it is. So here it did well on training data, when the accuracy is 100%, but on testing data, the precision score and the F1 score are 6% and 11% respectively. So here clearly it shows that the original decision tree is overfitted. And to avoid overfitting, after tuning the decision tree, you can clearly see that on training data, the accuracy is 99%, and while on testing data, the precision score is 97% and F1 score. So the tuned decision tree model has done far better from the decision. Thank you. And from now, Vishwesh will explain you further models. And yes, thank you.
Thank you, Rajit. Shes, if you could. Thank you. So, as Rashid discussed, we tried on the supervised learning algorithms and we were able to reach a total error of as low as 21 using the tuned decision tree. But to try and improve it more ahead, we went on to try ensemble models. So we picked bagging algorithm. So when we were trying bagging algorithm, the main hyperparameter is to define how many number of trees do we want in the algorithm to run. So that is defined using the n estimators. So after trying a lot of values for n estimators, we finally came up to the value 50, where we were able to reach the total error of as low as 11, where in this case, there are no single values who were not defaulters and were predicted as defaulters. So that was a very good output. And in the case where there were the users were defaulters, only 11 people were predicted as not defaulters. So this was a very satisfying output. But to try and improve it ahead, we decided to try the boosting algorithm. So in the boosting algorithm, we kept bagging as the base estimator, as bagging was working very efficiently earlier. And we kept the n estimators, where we are defining the number of iterations that it is going to take. So we defined it to 10. And so to all of these efforts, we were able to reduce the total error by one value, so which is also very helpful. So we came down to total error of 10. Next. So once we were done with this, we thought to give it a try using neural networks. So to try and implement neural networks, we used MLP classifier. Shreyas, full screen please. So when we were trying the MLP classifier, we were able to get the total error of 12, and we tried a lot of variations in the hyperparameters. So as mentioned in the graph, you can see when we use neural networks, we do it in iterations and we calculate the loss, so the data loss which happens there. So as shown in the graph, when we reached around 10 to 11 iterations, the loss is less than 1%. So that was a very good value for us, and the output was also satisfactory, which was 12. So we were happy with this also. Next. So we picked three models which were giving good accuracy, which was logistic regression, decision tree, and AdaBoost. And we tried to understand the accuracy using AUC ROC curve. So here we used the true positive rate and false positive rates ratio to plot this graph. So here the line which goes closer to the one value is the better model, and the one which goes like below the threshold value or closer to it is the bad model or worst model. So here, as we can see, the AdaBoost model is performing the best with 98.39%, followed by decision tree 97.46%, and then comes logistic regression, which is at 89.85%. So we can conclude that AdaBoost is the most accurate model among all of these three. Next.
Vishwesh, just a query here. Why did you use AdaBoost, sorry, the ANN wala thing in case of ROC?
Yes, ma'am. Yes, ma'am. So if you could remember, we put up a query to you that the same code for MLP was giving up different outputs in all of our three systems. So that was very confusing, and we were not able to correct that. So that's the reason we kept that aside.
But random state was passed there, right?
Yes, ma'am. The whole code, all the hyperparameters we checked that are possibly existing, and we checked like the default ones and the ones we updated, all were same.
Okay, so this best model that you got in case of ANN, who got it? You, Rachit, or Shreyas?
Share system, if I'm not wrong. Right, yes.
And how much was the difference?
Our systems got around, my system got 24, and Rachit's system also got somewhere around 24.
The errors?
Like from 20 to 30. Yes, total errors. And shares got 12.
Okay, fine. Okay, go ahead.
Yes, ma'am. So at the end, we attempted to try voting classifier, where voting classifier, what it does is takes multiple algorithms and runs all of them and predicts using the majority of the output of all the algorithms. So we passed the tuned decision tree, bagging algorithm, and the AdaBoost algorithm to voting classifier. So at the end, when we had all the outputs, we used this cross table to analyze and identify which models are giving us the best output. So here we found out that the AdaBoost and the voting classifier were the ones which were giving us the best output, with the total error as 10, which is the lowest amongst all. And both of them were giving the same output. Next. So as both of them were giving the same output, we decided to calculate their execution time to decide which one would be the optimal model. So now when voting classifier is getting executed, it executes all the models which we have passed to it. So it directly took double time than the AdaBoost algorithm. And as there was no significant difference in the output, we decided to declare AdaBoost as the optimal model based on the execution time and as well the number of errors it was giving us. Next. So once we were done and we found our optimal model as AdaBoost, so we decided to make it easy for the client to use our model for his further predictions. So we use this tkinter package to design a very basic user interface which would be extremely easy for the client to use. So he just have to run the program. As shown in the first picture, a very simple display would come where he has to select a file, CSV file, which has his data, the same as we were assigned by the client in the initial phase. So the model in the backend, the model will get executed, pre-processing, model evaluation, everything will be executed, and the total number of errors would be displayed on the screen. As shown in the second image, Here we passed the total data we had to this file, and we received 46,456 defaulters, which is 99, like more than 99% accurate. And also one by one, a prediction.csv file was created where the client can go and check the prediction for each and every user. So this was done for the user interface. Next. So once we were done with all of this, we decided to make sure, like, try and understand the data more and try to frame some recommendations for the client to reduce the defaulters in some other way. So we looked at the data and we found out that more of the defaulters had their term plan set to 36 months. Now we thought that if we suggest the client to take to suggest the borrowers to take the 60-month term plan, what would happen is the money would take a lot more time to come back to our client, like the financial institute, but they would have the assurity that the money is coming back, because extending the term plan directly affects the installment amount which the borrower has to pay, and also there would be more interest amount generated as the term plan increases. So this was our first recommendation, to suggest the 60-month term plan. Next. Then we went ahead to look at the purpose of the loans. So we found out that maximum number of people were defaulting where the purpose was debt consolidation. Now, as Shreyas earlier discussed, debt consolidation, it means that the borrower is taking the loan to dissolve his past debt. So maybe loans or any amount of money he has borrowed. So now this directly indicates that his financial planning is not going so well. So we initially thought that why not just reject all the debt consolidation loan types. But when we saw the number of amount of users who were taking this type of loan, it was the maximum, like more than 5 lakh. So we couldn't do that. So we found another way. So we can suggest our client that he approves the loan of this loan type debt consolidation only if the borrower is able to bring with him a nominee who has a good credit score and who would be liable to pay the loan if the borrower fails to. This way, the institution would be assured that the money would come back to them. Next. At the end, we noticed that all the data, all the users were segregated in grades. So when we saw the grades, users and defaulters, number of defaulters using grades, we found that maximum number of defaulters lie in the C, D, and B grade. So we can suggest our client that they should focus and try and improve their models for these particular grades. Now we can design a separate model for these grades. If we have like on what basis they have defined the grades, if we get to know, we can design a separate model for that. So the client can work on these grades specifically to reduce the number of defaulters, as they have more than 70% of the total defaulters. So these were like the recommendations we can make to our client other than the model we are providing. Next. So that was all we could able to do. Thank you, Shreyas, for the presentation. Thank you, Rachit, and thank you, ma'am, for this opportunity. That's all.
All right, guys. Just a minute.